Good morning, everybody. Let me log right in right quick.
Afternoon.
Oh yeah, my bad. It's morning in New York, so. All right, let's get this show on the road. Scroll up. So, play. Yeah, so, morning, everybody. I'm Iheanyi Ekechukwu. Today I'll be talking to you about gRPC and PROTOBUFS. So, let me reintroduce myself once again. I'm Iheanyi. I'm a software engineer at DigitalOcean. Quick show of hands, how many of y'all use DigitalOcean? Or use, yeah, perfect. How many of y'all don't use DO but have heard of us? All right, not bad, not bad. So yeah, I have my Twitter handle on there at Kuchu. But yeah, let's kick it off. So to start off, we can ask the question of what are protobufs? And we need to know we need to know about protobufs before talking about gRPC because it's kind of really important as a foundation. So protobufs are simply protocol buffers. And what this is a language agnostic method for serializing structured data. It was invented by Google, and it's pretty nice. It's just a nice way of defining your structure of your data. And we can kind of ask, well, how does that work? How does that happen? And you start off by defining a message. So here we have an example protobuf file. We are using a data model of a contact and a phone number. So to start off, you have this keyword message contact. Think of this as your class name. It's just simply what the data model that you're currently describing is. And all of these messages are made up of a series of attributes. I'm sorry. All of these have a tag, which is a uniquely assigned number, and a type. The tag is used to identify that attribute name inside of the binary format that protobufs compile to. And once you define that number tag, you shouldn't reuse it, and you also shouldn't change it once it's in use. And each of those types that you can define is an extensive list of scalar types. These are all of the types that are supported within gRPC, and they all map to some form of representation depending on the language. Dynamic or statically typed languages tend to have more definitions or type definitions around numbers, whereas dynamic languages, not so much. It's like more simplified. But yeah, another optional keyword that you can have in there is repeated. This is called a field rule, and what this basically means is this is an array of this type. So since we have phone number, some people have multiple phone numbers, so in a contact, we're gonna have array of phone numbers to keep track of that. And you can reference either the scalar types or another message type. So moving on to that, we can see that for the message type for a phone number, we want to have an easy way of saying what type of phone number is it, because nowadays people have a home phone number, well, maybe not anymore, but a work phone number and a mobile number. So you can use an enum for that, and essentially an enum is just like a simple type to be defined, and pretty much the rule to keep in mind for this is that the default value for that enum should be mapped to 0, and it also should be kept in order. And this is just a nice representation of predefined fields for you to use within your protocol buffer. And then after you have your message format or your message protobuf defined, you can just compile it. It gets compiled to a binary wire format. And what this basically means is that, like I mentioned earlier, each of those attributes have a tag or a uniquely numbered tag on next to it. And what that means is that it's basically how it knows what to encode. It's intelligent mapping of the attribute and its type per message. And so how do we actually compile them? Well, Protobufs ship actually with the compiler out of the box called Prodoc or Proto-C, however you prefer to pronounce it. And what we are able to do is specify what languages we want output with it and the protobuf file that we want to compile. So in this case, we're going to be generating a Go file with, from the protobuf definition and also a JavaScript file. But it also has support for C++, Python, Ruby, Java, Swift, Objective-C, and I think there's other ones as well, but those are the Go and JavaScript and Ruby are the main ones I use day to day. So yeah, that's our compile command. What gets generated from this is two files. You have a contact.pb.go and a contact_pb.js. And if we were to open up our Go file, I have a little snippet of what gets generated, but as you can see, the code that got generated maps to the typing or the schema defined within our protobuf file. So yeah, you see name string, email string, phone numbers. Once again, it's an array, like I mentioned earlier, the repeated value, and then a mapping or a pointer reference to the message type for home, mobile, work. And it's just not only that small snippet that gets generated. I was trying to, fit the entire generated file onto a slide, but as you can see, I kind of ran out of space. So just decided to focus on the good parts. And it's not only like these definitions that get generated. You get nice getters and setters or other data access methods that are generated onto the structs or onto the data objects. The format changes depending on the programming language. Like with Go, it doesn't generate them for primitive types, but for more complex types, like reference values to messages, you'll see those getter and setter methods. But like if we were to look into our JavaScript file, right, we'll have on the prototype for our contact, you'll see a get name, a set name, and it'll be the same thing for those other methods as well. So that's pretty nifty. So now we know how they work and like how to use them. Like, why should we use them? So, in a way, I personally think that it's simpler and easier to read. A lot of times, especially with some languages, it's hard to really figure out what the actual shape of the data model is. Like in JavaScript especially, at least with me, it's like if you use something like maybe like JSON schema or even like GraphQL or even like TypeScript or something, it like makes it easier to like define that, but like not everybody has a good way of documenting the structure of their code base. But like it's a clear definition of the data model. It's language agnostic, so you know that structure is going to be the same across every single language that you use. And yeah, I have a slide just saying language agnostic, meaning you don't have to use it like what you write for one, like you just write it once, compile it, and you get it for like Go and other languages and all that. It takes a lot of hard work and duplication out for you. And I personally think that this is just better and it's more consistent, and it's also serves as a form of documentation in itself because it's easy to read at a glance and know what's going on. And also, since it's a binary encoding or a binary format, it's faster. And when I say faster, it's faster in comparison to XML and JSON by like a factor of being 3 to 10 times smaller, and then becoming 20 to 100 times faster. Just because JSON and XML are textual format, whereas protocol buffers are just a binary format, so it's way smaller. And depending on what tag number you have, so all values from like 1 to 15 for the tag numbers take up a byte encoding of take 1 byte to encode their size, their attribute or the tag and its type, and then from 16 to 2047 it takes 2 bytes. So pretty impressive. And I also put stronger because you have a strict contract. You can't really break that contract. Depending on the language that you use as well, like I know in Ruby, it has some assertions on like the typing. So if you try to pass in an invalid type to a method, it will throw an error, say like you can't set it to that type of invalid type. So you kind of get like the benefits of typing, but not like at least the closest you can get in a dynamic language. And also, in order to change this contract, you have to regenerate the file or recompile the protobuf, and you have to be very deliberate about changing the shape of your data model and your data layer. And this really becomes important in gRPC, so remember to just the word contract. And like I said, type definitions are good, and depending on the language, it can be even better. And just simpler, So simpler, better, faster, stronger. Daft Punk approved. So now let's move on to talking about gRPC. And I want to define what gRPC is. A little bit of history behind it. It's an RPC framework that was developed by Google that serves as an extension of protocol buffers. Internally, they had something called Stubby, which they then, did the actual Google thing and open sourced it. And it's essentially the same thing, but just renamed it. And yeah. And basically what happens is it allows you to extend protobufs to define services and endpoints and automatically generate client and server stubs for your service. And it's used by various companies like Square, CoreOS, Netflix, DigitalOcean, and Visco. So once again, why would you use it? Well, first and foremost, it uses HTTP 2 under the hood. So in comparison to HTTP 1, HTTP 2 is multiplexed. You're allowed to have parallelism with one connection, and that multiplexing becomes a lifesaver in kind of these latency or performance critical functions. And you also get things like header compression, etc. I think that it takes security to the next level. Of course, you can have SSL and TLS with an HTTP service, but one thing that gRPC does enable is the ability for mutual authentication, meaning that it's not just encrypting that connection. You have to make sure, if you use certificate authority, you can make sure, hey, is this service that's trying to talk to me actually in the same trusted realm that and should be allowed to connect. And we use that to make sure that only our services can talk to one another and nobody from the outside can get in. And just defining, and whenever you're working with these servers and these clients, basically you can set deadlines and timeouts on a call. So sometimes you can have ridiculously long calls over HTTP, but unless the server errors out or something happens, it can go on forever, and it's just blocking and waiting. But you can generally say okay, well, if this request after 10 seconds hasn't completed, just cancel it or terminate it, and that allows you to be a good circuit breaker of sorts or stopgap or stop measure and if a service fails, it's pretty nifty. And by nature, you don't even have to set a context, a deadline or a timeout for that to happen. All RPC requests sent out or requested are cancelable by the programmer or end user. But that's actually, it's not it's an undo function, it's just more a stop. So anything that happened before you cancel that request, those changes will be persisted. Let's see here. And show of hands, anybody here ever been burned by JSON changes and nobody communicated it to you? It has to be way more than that. Yeah, don't worry, me too. And every time that happens, it's broken, and I feel like a huge loser. And yeah, so I don't really like that. But thinking about it, since you are using uniquely numbered tags with protocol buffers, it's safe to rename the fields inside of that protobuf file, right, to an extent. Because whenever it gets compiled, it doesn't necessarily care about the actual name that's assigned. It only cares about its number. So as long as you don't change that number, you're good to go. But there could be some data loss depending on how you're calling it from a client to a server, but it's actually really hard to really mess this up whenever you rename a field. And also, did I mention that the clients generated are backwards and forward compatible? And whenever I first found this out, I was because old client binaries, if you were to regenerate your protobuf and you've re-implemented it on the server, but you didn't ship the new binary to the client, what happens is that it won't break the old clients. The old client will still work as expected, but if there are any new fields added, it'll just ignore them, like the new fields, whenever it's talking to the server. So of course, if you add new fields and you want to update the implementation of the client, you should update the binary and add those new fields, but those that don't get updated won't be returning errors or anything of the sort. And yeah, since it's just an extension of protocol buffers, you just get all the benefits of protobufs. Just stronger contracts. Protobufs are strict contracts in a way, but that one's just a data a data model definition. But this becomes more strict as a contract because you're talking service to service, not just like a data model. So that way, if that changes, you can't change that implementation without, it becomes harder to break that contract. Because with REST, it's easy to break it just by simply doing something like changing an endpoint name, for example, or path, or even changing the payload that's returned, right? But these are way stricter contracts between the services talking to one another. And like I said, because it's a binary format under the hood, it's going to be better performance in comparison to JSON XML. And this language agnosticism is pretty clutch because, like I mentioned before, I can you could do the same thing with protobufs in generating client library, or generating these files for any language, but I can generate a server and a client for multiple languages. And even if I have a server written in Go, the Node.js client can still connect and communicate with it, and they cannot speak to one another. And that's really powerful, especially if your company is one that's like a polyglot company and there's multiple languages being used on the stack. So yeah, all in all, what I'm trying to get at is just something that's great for your microservices. Like at Dio, we have, well, I don't even know how many we have, but we have a lot of microservices. And we use gRPC for pretty much all of them, other than the legacy ones that we haven't quite gotten the time to rewrite into their own gRPC service. And it's nice to it's nice to use gRPC in a service-oriented architecture because it's just able to scale independently, deploy independently, and also, but you still have a strict contract that all the parts of the system need to abide by. So let's see. I'm going to talk about how it works next. And I think it's kind of hard to explain. I could explain oh, well, under the hood it does this and that, but I think it's just going to be good to build a simple phone book service and command line interface for using gRPC. So for the sake of showing the language agnosticism, I'm going to write the server, and I'm going to be using Go as the language for the server, and then for the client, I'm going to be using Node.js because we're at a JavaScript conference. So first, we're going to define our service, and we're going to be using just Proto3 syntax, and that reminds me, and with protocol buffers, there's two versions, Proto2 and Proto3. For the most part, you should be using Proto3 from here on out, because unless you have old legacy version 2, but gRPC only works with Protobuf or protocol buffers version 3, so that's important. So back to our service, we are defining a service called phonebook. It's going to be in a package API. And we're going to add an RPC method to create a contact, right? So here's our service from before. And it's going to expand to be calling an RPC method called createContact. That contact takes in, or that createContact method takes in a createContact request object and returns a createContact response. And for the sake of our request, if you remember our contact protobuf file from earlier, it's still following the same shape of that protobuf or message. So basically, for create contact requests, we want to give an input of name, email, array of phone numbers, and a home number, a mobile number, and a work number. And in the response, rather than we're going to just return the contact object that we created. And now that we have this protobuf file defined, what we're going to do is compile this with the gRPC plugin. So if you see our protobuf or prodoc or protoc compile command from earlier, what we have here is just compiling our API.proto file. You see that we mentioned that it has a gRPC plugin added to the go out command. And yeah, some good stuff. And once again, this generates the API or the api.pb.go file and api_pb.js file like we had before. But since we use a gRPC plugin, there's some subtle differences. So if you look at this code snippet again, we actually have an interface defined for our phone book server that has our create contact method defined within it. And as you can see, it takes in a create contact request and it returns a create contact response. And it gives us a means of registering that phone book server service on a gRPC server. And it's not shown here, but the client also gets defined within these files. So if I were to do or if we were to be building this with the client in Go, you'd be able to see the same interfaces defined on top of that phone book client. And yeah, same kind of logic. So now that we have this our generated protobuf file, let's implement the actual create contact method in the Go server. And I guess just to show of hands, I know it's a JS conference. Who here has written Go? How many of y'all write Go at work? Dude, maybe you're the only one. But hey, but that's awesome. But yeah, I kind of like Go. I really like Go. My background is front-end developer turned back-end developer to meet a deadline, and I've just been writing Go for like the last 8 months. Yeah, so here we have our server struct definition. So basically, I'm just using I didn't really want to use a real database for this, so we're just going to use a map using the name as the key, and that's going to be our server struct that we define the methods on. So with that, we're going to define our create contact method on that server. Basically, I'm going to have a validation, make sure the name isn't empty, because who writes empty names in a phone book? And basically, we're taking in those inputs from, or my bad, sorry, those attribute values from the create contact request and assigning them to a struct of a contact struct. And then we can just store that struct within our map with the value being that contact that we just created. And then we just can return a response object with the contact as a value to it. And yeah. Then the next step after this is to register the service with a gRPC server. And just so I don't like having like magic here and there, but like basically we're just going to instantiate the server in a new function. It just simply creates a new instance of our server struct. And then we're going to move to a main function. And what this does is that we're just going to create a TCP server on port 50,051, create a new gRPC server, and then register our service on that gRPC server and serve it up so it's just listening on that port. And after we do that, we're done with that, so not that difficult. So now let's implement it in our Node.js client. So basically, just to get started with that, there's 2 ways. So Node.js is an interesting language, right? JavaScript is an interesting language, like as we've seen by talks today. You can have 2 ways of working with protobuf files with JavaScript. I've been specifying JS out with the prodoc command like today, but when it comes to using it with like gRPC or even not without it, you can actually just import it like anything else just by specifying its path and using gRPC to load it up. And that gives it's kind of different from dynamic or statically compiling it, but it's still a nice way of like doing quick proofs of concepts with it. So basically what we're doing here is that we're loading up the gRPC package and then loading our protobuf file and getting the API service from it, right? And then we're creating a new client, as you can see, as we have a new API.phonebook that connects to the address of our gRPC server, and we're good to go. And also, you can see at the bottom, we have a little phone type. That's just a simplification of our enum from earlier. And then I'm just using the CLI package called Commander, created by TJ Holowichuk, if I hope I said that right. Basically, we're going to say program. Our command is going to be create, passing in a name as an input. And then we want to designate flags for the email, home address, or my bad, home number, mobile number, and work number. And then after that, we can just do make actions. Make an action that takes in all these inputs and this input and its options. And basically, you're seeing that we create a new API that create contact request, and we create an empty array. And then if options.home, we want to create a new API.phoneNumber object, set its type to be phonetype.home, once again, that enumeration. And then you want to set its number to be the options.home, which is basically whatever you input into the terminal, push it into the array, and then just set the request, to set the value of home on the request object to that home number, and you repeat, like you rinse, wash, repeat that with the work and mobile numbers. You can then set request.name to like name, request.email to options.email, request.phone numbers to phone array, and then basically notice that you don't have to call any API endpoint or anything like that. Basically, it's just RPC, right? So you just use call create contact, pass into request, function, it returns an error and a response, and you can check for that error, log it out, otherwise it's printed out as it is, and you're done. So not bad. And now that we got that ball rolling, let's test it out. So first, what we're going to do, we're going to compile and run our Go server in one terminal. So pretty much go install, the server and serve it up. And now we can try our create command for the CLI interface in another window. So basically, that command is going to turn into just create my name and mock number. Essentially, if you do that, that's what it outputs, right? Just a table of what was created. And yeah, it's pretty neat in my opinion. And then what if the input was invalid? Like if you were to send it into a blank string, what it will return is just that error message that we had or validation logic we had within our Go service with no need to map. And when it comes to gRPC and errors, what happens is that there's a library called status, and I actually wish I'd put the slide of that endpoint after this one. But basically what happens is that you have a mapping of status codes for whether it's a client error or server errors for things like, invalid parameters, not found, internal server error, et cetera, et cetera. And then you can return these errors back to your client, and the client knows what the status code is, and it also knows what the error message is. So it becomes pretty easy just to define constants that are just basically calls to these error objects in gRPC, import them where you need them in your Go service or wherever you're using it, and return it as necessary. And yeah, after it's building that, it's pretty easy. So, but it doesn't stop there. We could implement other methods for our service as well, for example, all of these, but nobody has time for that. So I have the repo here if you want to check it out in your free time. Yeah, I actually haven't written a README, so I need to actually probably do this after that talk to have instructions on how to build it and how to use it. But yeah, I highly suggest you take a look at it. But I just really scratched the surface of gRPC in my talk, because there's so much more that I can do that I couldn't fit in 40 minutes. You're not only constrained to actually using protocol buffers with gRPC, you can actually use gRP3 with other frameworks like Thrift, for example. But I think I personally highly recommend using Protobufs just because they're the most efficient and performant. It comes with load balancing. You don't only necessarily have to load balance via proxy at the server. You can actually do client-side load balancing, and the way that works is the clients can, whenever they communicate to a server, the server can send back a load report, and basically they can keep a running track of that. And what ends up happening is if they keep track of all the connections, they know what the load on each node is, so they can just send a request to the one that has the lowest load on it. And so that is a nice performance boost that comes shipped out of the box with gRPC. But it's kind of like dope to me. There's some things that have, or some languages that have more features than others, primarily Go and Java, because Google loves both of those. But basically, it has support for interceptors. So let's say if you're doing some repetitive logic, like whether it's logging, error handling, something of the sort in the same manner on every endpoint, you don't have to write that same code twice, or even multiple times. You can just make an interceptor for every single method, and it's smart enough to basically do that action on every single RPC method that you defined. And it saves a lot of time. And we also use that DO a lot for just logging metrics and what have you. And for people that have a lot of data, it also supports like streaming rather than just unary calls of a single request and a single response. With client streaming, rather than sending a single request, it can send a stream of requests to the server, and then the server can choose to respond with a single response and the status details, if applicable, like error code, or my bad, status code, and like the status detail. Server streaming isn't the request, but it can choose to send back a stream of responses rather than a single response after getting a request from a client. And then after it's done sending all of its responses, it will just send back its status details and status code if applicable, and then just close that. And they're not necessarily mutually exclusive. You can use these two at the same time as well. And you can choose how you want things to be handled. You can be like, oh, well, do I want this to ping pong, like do a ping pong type of thing? Or do I want the client to send all of its requests back and then wait for like all of the responses from the server? Like you can kind of choose your own logic for how to handle these type of situations. Like gRPC and the streaming API is flexible with regards to that. And I guess like a real world example of just thinking about it, what they use is like a ride sharing app. Like if you're in like Uber or Lyft. Do y'all have Uber and Lyft in Romania? Okay, cool, dope. Yeah, if you're using that, you don't want to send a request for every single, like, you necessarily don't want to make a request for every single, drive along the path. You can just keep a connection open and keep on sending a stream of your latitude and longitude as you travel. And that's a really good example use case for that. And you can also like attach metadata to like arbitrary calls if you want to attach more info to it, like location, like what client is sending the call, and anything else you want to attach to it. And gRPC has a really nice open source ecosystem. And once again, particularly with Go and Java, just because that's the languages that a lot of people use it with. But this is a good repo that has a lot of the plugins for it, or my bad, a good organization. And basically, it has support for things like Prometheus, if you want to do metrics and monitoring, distributed tracing via open tracing, it supports that standard. And even like if you want to make an API gateway and you want to use HTTP and JSON, you can use that. It has a gRPC gateway plugin that you can use, and that can translate your HTTP and JSON to a protocol buffer to another service. So I suggest taking a look at it and see what it has to offer. And in sum, gRPC enables new possibilities for building software, because I've been talking about this from a back-end, like kind of oriented, like focus, but it's not only just in back-end, right? It's like more of like or microservices, like able for like web, mobile, and even desktop, right? Because since it has support for Java and Swift, you can generate gRPC clients for your mobile applications that you develop, meaning that you have that strict contract, and it's hard to make breaking changes if you're using that client, that generated client directly. And even it'd be interesting to see how this plays out with like React Native and maybe even generating a gRPC client and then just making a bridge to the both of them, it could be a nice way of like, using gRPC within React Native applications. But then since it's using since Node.js has gRPC support as well, you're not only constrained to using REST, right? You can generate a gRPC client, import it into your Electron application, and use it to make RPC calls to your various services. And I think that's pretty nifty as well, just because I don't know, I like having everything defined as a function rather than having to type out a lot of the stuff. And something that's still in alpha, not yet publicly available, is gRPC Web, meaning that the power of gRPC is going to be coming to the web browser. And I'm really excited about that personally. And having everything be a function call and not having to memorize endpoints and having the API documentation essentially being your protocol buffer is what really kind of excites me about this technology and why I really enjoy using it. And this is just huge. And I don't know, have any of y'all ever heard of Improbable? They're like a engineering company, game server engineering company based out of London. But they made their own gRPC web implementation that you can take a look at. And it's compliant with Google's gRPC web spec and everything. But I looked at a repo, I'm like, oh wow, this is really promising. And just for further reading, I have just some links that y'all can go and take a look at. The ecosystem, the Protobuf documentation, Improbable, and gRPC official website. And thank you.
Thank you, Iheanyi.
Thank you.
How was that?
Oh, it's great.
Excellent, thank you. One question that I don't understand, so I'm just going to read it verbatim because I know nothing at all about GraphQL. But does it make sense to use GraphQL over gRPC? Is it a good idea?
I actually was just reading up on that the other day, and it kind of does make sense, right? Because those two play nicely with one another. Yeah, I think it does make sense. I personally never used it, but I think I may explore that out now that you mention it. But yeah, GraphQL doesn't. Let me think about how I want to word this. If you build out the API service for yeah, if you build out the API service, it's just one endpoint, and then you can make the relevant calls to the gRPC service. Yeah, I think it could work out pretty well, and even you probably could be able to figure out a way, at least I know with the Go implementation of GraphQL, to map the Protobuf to a GraphQL query or schema. So yeah, I think it makes sense. Good question.
And how do you debug requests and responses? Any tools you can recommend?
Requests and responses, debugging that. Let me think. I think, well, for one, I know Google ships a textual format for debugging gRPC requests and responses. Also, you can debug requests and responses through good old logs. But a good way of debugging what's going wrong are what we do at DO is that we use just distributed tracing. We use open tracing to see what's going wrong, and in our dashboard in our tracing dashboard, you can see what requests or what endpoints are returning a high amount of errors, the error that was returned, and what went wrong. And it also shows things like latency, which method or function call within it was the one that returned an error, and yeah. But that's also harder to set up, so just using logging probably could be a means of doing so, but other than that, I'm not quite sure.
Excellent. Are there any questions from the floor? Because my my laptop expired, so I haven't seen Twitter for the last 5 or 10 minutes. Any questions? Excellent. Then give it up for Iheanyi.
Thank you.